This is Jeff Kramer from DevX. In this screencast, we're going to talk about the Cloud Agents architecture, namely how it all works together to make a cohesive feature. So this is our architecture diagram. HP Cloud Agents is an API accessible service. Much like Swift and Nova, you interact with them via an API endpoint. Agents works the same way. So at the core of a lot of things, we have an API server. HP Cloud Agents stores its master data in a SQL database. This includes the tasks that you have set up and each specific run of those tasks. Our web UI and a public, like a CLI client or some other public client, talk to that API server. For certain secure things like user credentials and agent configurations, we have a crypto server that encrypts and decrypts things for us. So we don't know what the encryption, decryption keys are for a user. Those don't live in our main database. We have a dispatch server. The dispatch server's job is to say what should be run. So is there an agent task that hasn't been run yet but should be run yet? Once it finds one of those, it makes a request via HTTPS to some number of runners. Runners are web servers that live on horizontally scalable worker VMs. Usually, well, our idea is that we would have them live in Nova. So it sends a JSON object down that says, okay, we need you to execute this script for this tenant ID with this token. So the dispatch server generates some credentials for the user when we do this. The runner then calls a fetcher script and says, oh, I need this for this user. And we create a unique directory for that agent run. We download the agent into that directory, and then we execute the agent. And the output of the agent, the JSON messages that it produces, get pushed back up the stack and back into the SQL database, so clients can access them. Agents can also talk to the API server because it's a service like anything else, so they can authenticate it to it with their token. This means that agents can be self-modifying, or you could have an agent which creates new agent tasks. The possibilities are pretty wide open. Right now we're deploying all of this on one system, but it's designed to be horizontally scalable as much as possible. So we could have multiple API servers, a SQL database cluster, multiple dispatch servers, and lots of runners if we needed them. And because we're doing everything by tenant ID, we can shard this fairly easily, just based on some numeric property of the tenant ID.